Hi there everyone, we're now in our next video on number theory, and this is a continuation video of the theorem that we have discussed a while ago, that is theorem 3.5, and we'll be giving some examples of how the theorem 3.5 works. So first of the theorem, if you can recall, and maybe you can watch the video before so that you'll have a background of what theorem 3.2 is, rather 3.2 is. So it has the properties of congruence, some of the properties actually. So we have the reflexive property, symmetric property, transitive property, and the rest. And 4, 5, 6 properties, the parts 4, 5, 6 are all about operations. But let's start with some examples. So example 1 here actually shows the reflexive property, wherein if they are the same, given mod m mod something, meaning they're the same. So 6 is congruent to 6 mod 5 since by reflexive property. So this is the reflexive property, by the way. um, Reflexive property, reflexive, okay, property. Okay, so if you want, we can prove this. So 6 is congruent to 6 because 6 minus 6 is equal to 5, is equal to 0 rather, and then such that 5 is a factor of 0. That's correct, right? 5 times 0 is 0, so 5 indeed is a factor of 0. So that makes it true. For number 2, this number 2 is showing us the symmetric property, actually. A symmetric property. Okay, so we say in number 2 that if 3 is congruent to 5 mod 2, then 5 is congruent to 3 mod 2. So let's try to give some proof of why this is so, because 3 minus 5 is equal to minus 2. So 2 is indeed a factor of minus 2. So that's 2 times minus 1. And also here we have 5 minus 3 is equal to 2. So that's itself. So yeah, we can see that the symmetric property holds. For number 3, this is the transitive property. So for number 3, this is transitive property. Okay, so since 7 is congruent to minus 5 mod 4 and negative 5 is congruent to 15 mod 4, so therefore we can conclude that 7 is congruent to 15 mod 4. So yeah, so by transitivity, so we can check them one by one um, if you want. So we can say that 7 minus 5 is going to give us 12, and clearly a 4 is a factor. 4 divides 12. Let's check. Here we have minus 5 minus 15 is going to give us minus 20. So minus 20, 4 is indeed a factor of minus 20. Multiply that by negative 5. And here 7 minus 15 is going to give us what? Minus 8. So indeed 4 is a factor of minus 8. That is 4 times minus 2. So that's going to give us minus 8. So that's transitivity property. So we have shown some examples of reflexive property, symmetric property, and transitive property. Let's give a brief example of the operations here. So we can, after this part, we can say that we can compute some operations on integer, on arithmetic, or congruence, or in the theory of congruences, or modular arithmetic. So notice that 19 is congruent to 5 mod 7. So we say that 19 plus 11 is congruent to 5 plus 11. As you can see, the ones we added to both left hand side and right hand side of the congruence is the same. So if we're going to add them just like in equality, it's going to be just the same. If we're going to deduct, it should be the same, so it will still be good. If we're going to multiply, so it's still going to be the same, provided the modulo are all the same. Of course, it will be a different thing if we're going to change the modulo, so that's going to be not congruent. Okay, so if you want to try, so 19 plus 11 is going to give us 30. This is going to give us 30. It's said to be congruent to what? 16. So let's try a 30 minus 16 is going to give us 14. And yeah, 7 divides 14. That's, yeah, 7 times 2. Here, 19 minus 11 is going to give us what? 8 is congruent to 5 minus 11 is going to give us what? Minus 6, right? So we have 8 minus minus 6 is going to give us what number? Still 14. Okay, so again, 7 divides 14. Also, we have 19 times 11. That's going to be 209, correct? Vedic maths. This becomes 110, 9. So that's 209, correct? Next is we'll have 5 times 11 is 55. So 209 minus 55. Oops, that's 0. 209 minus 55. So let's subtract 55 here. Going to give us what? 15, 4. So the answer is 154. So the question is this divisible by 7? So let's try. Let's try. 154. Let's do it here. Divide by 7. That's going to give us 2. This is 14. This is going to give us 1, 14. Yeah, that's 22. Then this will become 0 at the end. So 22. So if you want to recheck 22 times 7, it's going to give us 14, 14. That's 154. So that indeed 7 divides. Indeed, 7 divides 154. Okay, so that's the main thing in theorem 3.2. Actually, if you have a congruence, if you have something like this in the congruence, if you're going to do something with the left hand side, you will need to do it with the right hand side in order to preserve the congruence, provided that the modulo is not changed. Okay, so we will end this video with this statement. Now, by theorem 3.2, what is the thing that is very important in theorem 3.2? So it follows by theorem 3.2 that the congruence relation, the one that we're talking about since the start of all this, is also an equivalence relation. Okay, so a congruence relation, congruence is also an equal relation. It's also an equivalence relation, provided the modulo is not different, it's not changed. Because an equivalence relation is a relation that is reflexive, symmetric, and transitive. Okay, so the equivalence, the equal sign, using the equal sign. So the congruence is just using the congruence symbol. So yeah, so we can say by theorem 3.2, congruence relation is also an equivalence relation. Okay, so that's it for this video. Thank you for watching, and I hope you will like and subscribe. Okay, see you soon. I'll be creating more. Thank you.